A typical question of IB that you need to be able to answer for kinetics is to come up with rate expression. Now, rate expression is always written in terms of reactants and their concentration. So eventually you have to come up with an equation that is written as rate equals to a rate constant times concentration of one reactant raised to a power x. We have to find what x is, and the other reactant b to a power y. The x and y are known as order of reactions, and when you add it up, it's overall order. And simply their definition is the exponent, or the power by which the concentration changes the rate of reaction. So this is order of reaction with respect to reactant A. Now, intention of the experimenter usually is to hold the concentration of one reactant constant, like B, and change the concentration of the other reactant and see what is the effect on the rate. So I'm going to take experiment number 2 and divide by experiment number 1 in order to find the x, or the order by which A is changing my rate. So experiment number 2 divided by experiment number 1 is equal to rate of number 2, which is 4.50, divided by 0.50, equals to a constant k times concentration of A, 0.30, raised to power x, times concentration of B, 0.10, raised to power y, divided by the other rate, which is rate of number 1, k times 0.1 raised to power x, 0.1 for concentration of B raised to power y. Now we have three variables, k, x, and y, but by this division, k's cancel each other out. And by choosing a constant concentration, I don't need to worry about y, because 0.1 divided by 0.1 is 1. 1 raised to any power is equal to 1. So I can even cancel this out. So I only have one variable to solve for. 4.50, my rate, divided by 0.50 is equal to 9. And 0.3 divided by 0.1 is equal to 3 raised to power x. So now you can guess what x is. It should be 2, or second, it should be squared. So x equals 2. That's the order of reaction with respect to A. Now, in order to solve for y, I'm going to go after another reaction which A's are constant, which is experiment 3 and 2, and I'm going to compare them. So I'm going to this time divide experiment number 3 by experiment number 2. The rate is 4.50 equals k times 0.30 raised to power x times 0.20 raised to power y, divided by the experiment number 2, the rate is 4.50 as well, equals k times the constant 0.30 to power x, 0.10 to power y. Now notice that x we just solved for, it was 2. But whether you put that or not, this is like 1 raised to power 2. So this will go away from your equation. K's will cancel each other out. So you have 4.50 divided by 4.50, which is 1, equals to 0.2 divided by 0.1 is 2 raised to power y. Now at this stage you should realize y has to be 0. Anything raised to power 0 is equal to 1. So y is 0 order with respect to B. So now I'm ready to write my rate expression. Rate equals k, rate constant, which is function of temperature only, times concentration of A raised to power x, which we decided is 2, times B to power 0, which is 1. So I'm going to reduce this into rate equals k times A squared. I'm almost there, except this time they say determine the value of the rate constant and its unit. Using experiment number 3. So I'm going to apply the information. Rate of experiment number 3 is 4.50 equals a k times concentration of A is 0.30 raised to power 2. So K equals 4.50 divided by 0.30 squared. This happens to be 50. Now what is your unit? Your unit is always concentration to power 1 minus overall order. Let's see what is overall order. Times the unit time, which in this case is second minus 1. Overall order is sum of x and y. In this case, it's 2 plus 0, which is 2. So its concentration is molarity 1 minus overall order, which is 2, times second minus 1. So it is molarity minus 1 times second minus 1. Now, for sake of IB, we are going to open it up. Always remember molarity, which is, for us, it's mole per decimeter cube. So I'm going to plug it in. Therefore, the units of K is 50, mole minus 1, dm minus 3 times minus 1 is plus 3, second minus 1. So my rate expression is given. My K is calculated and its unit is also offered.